In the following video, I will show you how to answer question 9 of the January 2009 OCR Core 4 paper. Again, a question on differential equations. Here we go. It tells us a liquid is being heated at in an oven so that it has a constant temperature of 160. The rate of increase of the temperature of the liquid at any particular time is proportional to the following. So, if theta is the temperature, the rate of change of the temperature with respect to time is proportional to, and we're having an increase here, 160 minus theta. So in particular, d theta by dt must equal some constant of integration, let's call it k1, 160 minus theta. Write down the differential equation connecting theta and t. I've done that here. Here's a differential equation. We've got theta, we've got dt in it. Okay, then moving on to the second part of the question. It says, well, let's just remind ourselves what we said in the first part. We said d theta by dt was equal to k1, okay, and we said it was 160 minus theta. Okay, when the liquid was placed in the oven, its temperature was 20 degrees. Okay, so we've got that when t is 0, theta was 20 degrees. And 5 minutes later, its temperature had risen to 65. So when t was 5, theta was equal to 65. Find the temperature of the liquid after another 5 minutes. Well, what we're going to have to do is solve this differential equation and use the boundary conditions to find the constants of integration. When we've got a particular solution, use it to find the temperature after another 5 minutes. Okay, how are we going to solve this? By separating variables and then integrating. Divide both sides by 160 minus theta, multiply by dt, and integrate. All in one go, we would get the following. The integral of 1 over 160 minus theta with respect to d theta, must be equal to the integral of 1 times k1 with respect to dt. So if we integrate both sides, this integral integrates to minus ln 160 minus theta, and this here integrates to k1 t, and we're going to get another constant of integration which I'm going to call k2. Okay, now I know some values of t and theta. I know that when t is 0, theta is 20. So substituting those values in here, this disappears. I would get myself that k2 must be equal to the minus ln of 160 minus 20, which is 140. And I've got myself k2. Now let's try and find k1. Actually, let's just write out what our differential equation at that point has a solution of. Ln 160 minus theta must equal k1 t minus ln of 140. Okay, now I want to find k1, so I'm going to use the fact that after t is 5, theta is equal to 65. Subbing this in here, 165 minus 65 is 99, so I would get minus ln, 95 would be equal to 5 k1 minus ln 140. So in particular, what's k1? Well, k1, if I add ln 140 to both sides and divide by 5, I would get ln 140 minus ln 95. All of that divided by 5. Using our ln rule, ln 140 minus ln 95 is going to be ln 28 over 19, dividing 140 by 95. So this is ln, this would be a fifth, taking out that 5 there, a fifth ln 28 over 19, 28 over 19. And hence I've got my full solution now, which I can write out. It's quite complicated, but my full particular solution is ln 160 minus theta is equal to a fifth ln 28 over 19, lots of t, minus ln 140. Now, I wanted to find what the temperature, i.e. theta, is after another 5 minutes. So that's when t is equal to 10. So when t is 10, I need to substitute 10 into this and solve for theta. So I would get minus ln 160 minus theta, and I'm going to substitute in here, well, 10 times the fifth is 2 ln 28 over 19 minus ln 140. So I need to work out this whole side here. So I'm going to tap that in my calculator. 2 ln 28 over 19 and minus ln 140. On this side I'm getting minus 4.166, so this is equal to minus 4.166, i.e. minus ln 160 minus theta is equal to this. Okay, cancel the negative on both sides, take exponentials of both sides, so I would get 160 minus theta would be equal to e to the 4.166. Keeping that number exactly in the calculator and not rounding at this stage. So taking exponentials there, I would get that 160 minus theta is equal to 64.46, and solving for theta, theta therefore must be equal to 160 minus 64.46, and I get the answer 95.5, which to the nearest degree I get theta being 96 degrees Celsius. I hope you found the following useful in your revision for differential equations in Core 4. Thank you for watching.